Thank you, Ivan, and good morning to everybody. Good evening to Australia and to Korea. It's really a pleasure to see so many. Let's say I'm looking at the list of names here on the agenda, and I'm seeing from A to Z, and there's so many new names I don't know. This is really great to see new faces, new people. Hopefully we will see you again in the many upcoming online events. So today it's the final session on the WWW briefing event. This is session number 9, and it's well, it's as we call it, it's an extended Europe. Actually, Europe extends geographically from Azores, as we heard yesterday, to the east until the Urals. That geographically the whole Europe. Often we talk about and think about Europe as too narrow thing. It's often when I look at the say European news and the weather of Finland, where I come from, is always missing from the European map, and that sometimes upsets me. But today we put the things in order. So it's me and Lara. We are colleagues, and we have been working together already for a few years. This photo is from a workshop in Sochi a couple of years ago. We were up on the mountains on the future upcoming Winter Olympics venue. Lara, as you can imagine, she's an aviation forecaster, and Lara will introduce herself soon. I'm more like a conceptual model man, and of course I cannot help talking about conceptual models today also. Before I give Lara the microphone, just to show you an image of the, don't look at us, but look at the map behind you. So you see there's a, Russia is, of course, it's rather big. It's something like this, and it covers, I think Phil Chadwick told us a couple of days ago that it's the largest country in the world, but I picked the information that doesn't have the longest coastline in the world, so there's something bigger. But still, Russia only covers this much. Think about how much EUMeTsat covers. EUMeTsat covers more or less everything. We have the satellites covering the whole globe. This is the METOP A satellite swath on globe on one day. So in a way, I'm happy to say that today EUMeTsat is competing with Russia, who is a bigger one. On the World Weather Briefing, I just skipped and move to the next slide, and Lara, it's your turn, and you can introduce yourself. Please go ahead.
Good morning, thank you, Vesa. Good morning for Europe. Good time for the day for everybody. I'm happy to see so many people online, and let me introduce myself. As Vesa said, I'm Larisa Nikitina, and at that moment I'm working for Roshydromet, Russian Federal Service for Hydrometeorology. Its aviation department, Aviamet Telecom, as aviation weather forecaster in Rostov-on-Don, South Russia. Since 2010, I was involved in weather information service for Sochi 2014 Winter Olympics, and my second place of working now is Sochi. Don't worry, I'm going to tell you more, a little bit more about Sochi and Olympics in the second part of my presentation. But as for now, I'm not in Sochi or Rostov, I'm in the Urals. Urals, it is a mountain that separate European part of Russia from its Asian part, Europe from Asia, and I'm at the town called Chelyabinsk. It's approximately 1,000 kilometers east from Moscow. And it is a very famous town now because of some events that happened in this February. If you know what I'm talking about, click yes or no button. I want to see how many people who do know what I'm talking about. Oh yeah, somebody knows, somebody not. Okay. Okay, then I'll tell you. This event is called Chelyabinsk Meteor. It happens at 15 February this year. So to start my presentation with some interesting things, I want to share you a couple of slides. For meteorol fallout, we call it Che meteor because it was going via Chelyabinsk town and fall down in Chebarkul Lake. There is my favorite photos of meteor, especially the right one, where you can clearly see the thermal effect of Che meteor. And also I want to show you some satellite images of meteor taken by different countries, not only Russia, images that help to understand some details of its entry and that can be seen by surface, from surface. This is the image of condensation trail behind the meteor as it entered the Earth's atmosphere. The image has been captured and analyzed by Colorado State University scientists in partnership with NOAA. The next one is the images from EUMeTsat satellites Meteosat 7, 9, 10. It is infrared, visual water vapor and thermal images. I think it is quite interesting to see all these images because all the time of meteor fallout and its moving via atmosphere was less than half an hour. And the third slide is the Russian satellite images from Electro-L and Meteor-M. Images was provided by Russian State Research Center Planeta. The left one is a composite image from 3 channels from the geostationary Electro-L satellite, taken while meteor was going via Chelyabinsk city. And the right one is the image from Meteor-M that was able to see only shadows after meteor fallout, as polar orbited Meteor-M satellite was going via Chelyabinsk region only a half hour after event. And next I want to give you a small quiz, but I think it could be better your home task. Have you ever wondered, as I wondered doing this presentation, what's the difference between asteroid and comet, meteor and meteorite or bolide? And what is the correct name for this Che event? I have done some infographics at the left about Che meteor, including some information about it. You can download a large version of these infographics from this page and compare it with infographics of American Meteor Society to the right to clarify to yourself the actual situation with Che meteor. And again, I repeat, it might be better your homework. I will not tell you about it now. And the last slide of my brief introduction is the information that I want to share with you, that Chelyabinsk meteor and me, we finally meet each other. Why I tell so? Because Chelyabinsk is my birthplace, the meteor fallout place is my birthplace, and the meteor fallout day is my birthday. I can tell you more that it was my anniversary day. So I can see some interaction between them. Thank you. Now, let's return from sky to Earth weather, and I am giving microphone to my partner Vesa, who is going to tell you a lot of interesting things, I hope.
Thank you, Lara. Yeah, so you have something to remember for your birthday. Congratulations. Yeah, okay, this was interesting. I think it's, I hope it still stays interesting. We are now moving from the sky down to the earth. And as I said, I'm working with the conceptual models, and because this is a worldwide weather briefing week, I want to somehow take into the conceptual models as well into this final session, and also include some of the conceptual model thinking in the weather briefing. We normally have this weather briefing in Europe every month, but this month we are kind of replacing it with this larger event, so we don't have a full 45 minutes for the normal usual European weather briefing, just a very brief overview. But let's think about the conceptual models, and I know that many of you, I'm very happy to see that we have already 57 sites, so there may be some completely new faces as well. But those of you who have been maybe following this event during the week, you might like to do this little exercise. So let's stay and spend a couple of minutes of thinking about the whole week that we have had 8 sessions before this one. So you have 8 presenters there, actually 2 from South Africa. You see there is a little tool for you available there on the top where you can choose arrow tool. I see already some people are starting to combine, so use the arrow or line tool and connect the faces with the conceptual models. Some people are unable to make a straight line, but that's fine. Just use a couple of minutes and then we'll have a short kind of a summary of this week. The lines are increasing. Soon it will become impossible to read, but it's still fun. Okay, I see. I see some convergence of the lines. So, well, I can already start somehow summarizing. If I start from the left top, so it's Humberto, who was, of course, he was the South Atlantic Convergence Zone guy. He talked about the ITZZ and the convergence zone. Dan Picos, he was presenting on Monday. I was then on holiday, so I had not the pleasure to join this session live, but I only listened to the playback later on. And I understood that he was talking about the tornado, and well, that was very actual at that very day. So tornado is one of the conceptual models when you think about describing somebody somewhere about what did you see, and if you see if you try to describe the tornado, you can use a lot of words, but if you say I saw a tornado, people already have a mental image of what it was. Kim, okay, she was talking about typhoons. Diamantino, yesterday I picked up one word from his presentation, that was atmospheric rivers, if you remember. Mahmoud from Oman, he was mentioning one of his slides, the summer sea breeze. So that's also one of the conceptual models, a small scale conceptual model. And Phil Chadwick, this is a younger version of him, was presenting deformation bands, for example. That's his favorite topic. And Leanne and Yanni, they had a couple of conceptual models. Cutoff low was one of them. So you see that every presenter has used conceptual models during this week, so there must be some sense in using them. And just to show you an example of some of the screen captures I took of these presentations during this week. So maybe everybody remembers that this one on the top left, that was Dan Picos about the tornado. That was a sketch. This was from Bodo, the shallow cold front. This was from Leanne and Yanni about the cutoff low. You see the handwriting and the really nice, it's very, you see it's just a handwritten thing, but for a human eye it's very illustrative. This one on South America, this was Humberto's South Atlantic Convergence Zone. Again, just a very rough sketch, but the human eye catches the essential things very quickly there. I loved especially this one on the left, the Mahmoud's short summary, more or less, what's the summer type weather things and weather features taking place in Oman. And with just this one slide, I more or less get everything I need to know about the Oman climate in summer. And on the top right, you see, okay, his classification of different cloud patterns of typhoon. Again, a very nice slide. So for me, as I have been working with the conceptual models for a very long time, the conceptual models for me, they have been a tool to somehow understand the weather to get rid of the normal pixels and grid points that the models and the satellites offer us. Of course, they are really nice and they are fantastic to have a good resolution models and so on. But if we only look at these details and if we only look at the model output data, we may miss the point and miss the big picture. So conceptual models, at least for me, they are tools to somehow visualize the weather, and they are also a tool for me to explain the weather, not only to my colleagues, but also to let's say general public. For example, just spend 1 minute thinking about if you have to explain, let's say you have a radio interview, you happen to be on a forecast shift, and you have 1 minute to explain something that just happened. I think that you are very happy that you can use a conceptual model, for example, explaining that this was a tornado event and or it was a downburst. People can always remember these core words. And in that way, I think the conceptual models are even more important nowadays when we have only a little time slot to explain people what it was. So now moving to actual satellites, conceptual model and satellite images. Does anybody have an idea what this image is? I'll give you a few moments to think about. If you want to answer, you can raise your hand and give a good guess. It's very old, yes. Bodo has a suggestion. Please go ahead.
Yeah, it looks like a picture out of one of the early satellites looking down and back upon the Earth. It may even be one of the early Apollo missions where they maybe did some spacewalking and so.
Good guess. Lara, do you want to give an answer to Bodo?
Yes, it is a photo made not by satellite, but it is the first man-made photo of our Earth. It was made by second cosmonaut spaceman Titov. Let's see.
1961 was it?
Let's see the next slide.
Yes, so it was 1961.
It was Vostok spacecraft, Vostok 2. Vostok 2 spacecraft.
So I just took this image Lara had provided to me earlier, and it's just to illustrate that you get so much more information when you finally go up on the air and see the clouds from above. So for me, that has been this is of course a man-made photograph, and it's not a satellite image, but we are in a way it's a very good way to look at the weather from above. So this is now just a illustration of how I have been and how well the group of people that have been working with the conceptual models here in the EUMeTrain project have been working on them. So we have the image. We always start from the satellite image, and then we try to make analyses and try to find the physical reasons for why these images look like this. For example, this one here is a so-called occlusion cold conveyor type, and there are some schematics there as well just to highlight the important features. We have can combine them with the physical background, so we often combine these things with the conveyor belt thinking or with the dry intrusion and so on, just to explain why do we see the satellite image, the features like we see them. Also, we like to somehow diagnose the systems and classify and find some helpful tools how to define the conceptual model as we do. So we use key parameters for that. The key parameters are essential parameters that have to be fulfilled in order to classify the system as we do. So in this case, this is just an example of this cold conveyor type occlusion, where we have added a key parameters like height contours at 1000 hectopascal, surface low, and we have some height contours at 500 hectopascal. Of course, there are more key parameters, not only these, but these are just some of the examples. All this has been catalogued and documented in the Satmani project already many years ago, and now at the moment we are working further on this to also have more let's say more harmonized documentation for the Southern Hemisphere. Bodo and many colleagues from the Southern Hemisphere are working together to create more resources for the Southern Hemisphere on this. And finally, of course, everything is connected to the weather events, so that's where we have to fill to make it complete the whole description of the conceptual model. In the whole idea, as I said, is to give a three-dimensional weather picture. Well, if you think about the forecaster, of course, one good purpose would be also to check the model performance, to maybe perhaps compare the ideal model with the actual with what is actually happening at the moment. But for me personally, the main effect has been that when using conceptual models, I'm also using the available data more effectively, knowing that there's so much data around, and then when you somehow condense it into a meaningful models and conceptual models, it helps you to use that data more effectively, and also take use of the satellite information more in a better way. We do have in the weather briefings here in Europe often the approach in conceptual model wise. We have these every month, and we often like to let's say describe the weather on the satellite image using these models. Often nowadays we also we often like to have some featured talks as well, or special presentations. Maybe sometimes there has been something very interesting taking place during the last recent month, and then there's some expert or somebody who was actually living through this situation can make a short presentation. Everything is nowadays possible because we are all connected via online, so there's no restriction in traveling, or so it's really easy to set up these events. And these events, of course, they are open to everybody. You just sign up, you use the Sava meeting. I'm pretty sure that everybody now knows how to register to Sava meeting, and more information you can find from the EUMeTrain homepage. We also, well, I try to somehow now I'm trying to click on something, and I hope it doesn't crash your machines, but there's also the weather briefings will be always recorded, and they will be also able, you can always find them on the YouTube later on. Just click on ePort weather briefing, and there you'll find the most recent weather briefing. We also have from EUMETSAT, we have so-called monthly satellite weather that you can also find on YouTube. I can try to click on that. I hope it will work. So this is if you click that video, you should be able to see the Mark Higgins there describing the past March weather, and it only takes about 8 minutes for him to describe the whole March weather in Europe using just one satellite product. And I think it's a very nice way to go back to and see what was happening. So now I think it's time for me to move to the actual briefing part. And let's start by circulating through the whole globe. And again, now because we are so many, we are 57 sites at the moment, so you take your time and you can use again the star just to, when you see your country or your location on the map, just click on the map, so we'll see what kind of weather we have. So this actual map is from 06 UTC. That's why the left part of the image is still in the darkness. So you see most of the people are coming from Europe. Roro, I think your turn will come very soon. Thanks. So we'll see that there are on the Iberian Peninsula there is nothing really dramatic. At least it seems to be sunny. The worst weather in Europe actually at the moment is somewhere in the UK and the southeastern part of Europe. We'll get back to that soon. Let's try to take a look on the next satellite. That's also EUMETSAT World. So it's a Meteosat 7 over the Indian Ocean. Again, if you find your location in the map, you can just feel free to put the star on your location. I'm not an expert on the tropical weather or on the Indian Ocean weather, but it looks like very dry conditions now on the India and the Middle East and the most part of south of Urals. Let's move again further to the east. Now this is MT-SAT-2, and I think at least now, okay, he should be able to tick her location there. So Bodo is still, I think Bodo, the sun is setting for you now. This 06 UTC, so you are more or less in the darkness zone. Renato is asking about sun glint near Japan. Renato, can you click the point where you, oh yes, you mean, probably you mean this place here. This could be a sun glint. Okay, let's move to the further to the east. So now this is go west. This is now infrared because it's night there. Something really interesting over here. Big thing over there. Strong convection, and we see this nice line. Hopefully Bodo knows better, but it looks like intertropical convergence zone to me, Bodo. I hope I'm right. And the last one on the go is east, and now we are on the Western Hemisphere, so to say. If there's anybody from South America now, there's a chance to tick, but I think it's deep night at the moment in South America, so there are no colleagues joining in. Okay, so that was the full world weather briefing in just 2 minutes. Let's concentrate on the Europe. This may take a few seconds for you to load, so please tell me when you see the animation by clicking yes. It may take even 1 minute. It's 2 megabytes, and sometimes the connection may be slow, but it seems that everybody's seeing it already. So this is now this morning, and you see, yeah. So again, people, if you like to just to highlight where are you at the moment, so we can maybe just concentrate on certain parts of Europe. But as you see, I'm just highlighting some of the places I'm going to look more closely. This one is here, the low pressure center east of the UK, and also something over here, still not so very intensive, but let's say Southeast Europe and UK are in my radar today. Okay, thank you. This is the meteor alarm today, this morning, and we see a couple of warnings there. Can you guess what's the warning now at the moment in the Scandinavian countries? For example, in Finland and in Norway we have warnings, but they are not really weather warnings. Any guesses? Nope, it's not UV this time. Not waves either. Forest fire risk, that's correct. Laura guessed right, it's a forest fire risk. In Sweden it's not the forest fire, but it's the flooding of the, the winter has gone and the spring and all the big rivers are full of water, and there are flood warnings now in the northern parts of Sweden. In Austria and in Austria the warning is for very high and heavy rain, also in the northern parts of Germany. Here in the central parts of and southern parts of Germany there are warnings also, but they are not because of the rain, but because of the frost. We have unusually cold weather at the moment in Europe. This is now just back to the surface. This is our surface analysis that is made by the German Met Service, and you see the frontal analysis over there. You see the warm air mass over here is streaming from south and southeast and pushing towards north, and we see the low pressure over here. So let's get back to the satellite images. So can anybody tell me what's strange in this satellite image? Bodo, please. Oh yes, I see there are already also answers in the text chat box. It's looks like NWP. Mark, welcome back. You are online.
Sorry. did you just hear me, Visa? I might have pressed the wrong button, but yeah, looks a lot like the synthetic satellite images that we also generate over Australia and Indonesia.
Exactly, Bodo, and everybody else in the text chat box. It's an artificial satellite image. It's called pseudo image or synthetic satellite image, as you wish. If you compare it with the real one, now I could do the same thing as Bodo did the other day, just switching between the real and the artificial one. So artificial one or simulated one, real, simulated, real. So people, you can again, let's see, I clean these stars off, and now you can start you can tick a star where you think there are discrepancies between the model and the real atmosphere. Some people already see yeah, there is something real convection taking place in the Bulgaria, which is not so well represented in the model. There are some signs. Also in Russia, in southern Russia, you see there's I think it's more lumpy cloudiness in the warm sector than in the model that the model suggests. Convection is often not well represented in the model, so you see most often these discrepancies. Also in northern Italy there is something discrepancies. Also somebody found something in the southern Spain, something in the Azores, or near Azores, let's say, not in Azores but south of Azores. And also I found something also here. If you look at the well, I could try maybe use the highlighter or something like here. You see there's the front is more or less drying out, and the model still keeps there's a signs of drying out of this front, but it's even more pronounced in this in the real atmosphere. I like these very quick comparisons of how the model sees the atmosphere and then comparing with the real one. Okay, and now as normally we'd like to do the briefing, and this time I'm just using 2-3 minutes to the briefing just to show you that in the general sense we have the really, let's say, bad situation in the central parts of Europe. It's a big upper level low circulating over here, and we have cold air here. Only the warmest air is now at the moment in the easternmost parts of Europe. So it's for the season it's very cold. On the front, this is now the same image but with the fronts included, so you see that the main frontal activity is again also in the southeastern part of Europe, also in Russia, and then the new fronts coming up from the west. This curling front just east of the UK is also very interesting, and this especially this low pressure that I will show you very soon. In the main sea level pressure you see this deep low very nicely. And let's take a little bit of a zoom into that UK thing. So this is the ECMWF winds, surface winds, 10-meter winds. And UK is now here, so London is somewhere here, and the southern part of Norway is here. So this is the North Sea, and there's the center of the low, and the ECMWF suggests something like 20 meters per second. So the red barbs indicate something like a gale force, strong gale force winds. But if you compare it with the recent Askat wind overpass, we are lucky to have that Askat overpass just now. There's some discrepancy there. I don't know if it's really real, but if I look at the most strongest winds in the actual observations taken by the satellites just a couple of hours ago, they indicate that the most strongest wind is just east of the UK coast. I didn't have time to really confirm this or verify this, but at least as an idea, comparing the model and observation in this way would be an ideal way for you to also come to validate how good the model is doing today. Moving to the Southeast Europe, the most unstable part of Europe, more or less. Now we are looking at the cyan fields. They are now the 300 hectopascal height, so we have this large trough more or less, and the PVA maximum over here. PVA is the positive vorticity advection, or maybe it's better to say cyclonic vorticity advection, because we have southern hemispheric people here. So this is the actual maximum of that, and we have also some development over there taking place. And if you compare it with the CAPE values available, we have already quite high values of CAPE even early in the morning. So it's likely that this area in Europe will be prone to strong convection today. This is just very general overview, because we don't have too much time to go into details. So that was more or less of the ePort briefing for today for the western, or let's say the western and central parts of the Europe. And now I take you back to Lara. You have been hearing me enough. Lara, I hope you are still awake, and I just move back and you can take a bigger part of the globe now. Please go ahead.
Thank you, Vesa. Excellent weather briefing as always. What can I add to this? I can only tell about some eastern part of Russia. And as you remember, at the beginning of the presentation, Russia is the biggest country of the world. So to check all the Russian weather, it needs a lot of time. We have now this time. So I'd like to briefly show you only some Russian weather products that are available for population, for people on the official page of Roshydromet. And some maybe features that you can see may be interesting for you, or maybe you can find some conceptual models on it. But I will do it very briefly, very quickly, because I want to show you more about Olympics. This is a surface weather map, Roshydromet surface weather map from 0 UTC today. We can see all these cyclones over the Europe, and some very deep cyclones over the far east of Russia. And the central part of Russia, it is high pressure system. And if we take a quick view, a quick look at the satellite images from infrared, water vapor, it needs a bit time to click, and combined map with infrared image and thermobaric map, that we can see that very deep cyclones over West Europe, over Europe and over Far East Russia is connected by station front at the south parts of Russia near the border with China, and almost all the part from Ural and till east Siberia is covered by high pressure system. So if I look out of my window, I can see a very bright new day without any clouds on it. So this is the view of Chelyabinsk region, the city of Chelyabinsk. The next slide is Doppler radar map. We have some Doppler radars just installed in only west part, European part of Russia, and in some Doppler radars we can see growing in cumulonimbus. It is a radar from the morning. And I want to show you an animation. It can take some time. This is Cosmo model, Cosmo RU 7 kilometers resolution model. Some time from today, from the evening till tomorrow morning. So we can see that nothing interesting will happen on the eastern part of Russia, only anticyclone and growing anticyclone. Next, it is the Cosmo RU meteograms for Chelyabinsk. We can see at the official maps a lot of meteograms now for different countries, for different cities, and at that meteogram for Chelyabinsk we can see nothing interesting, only growing temperature and some clouds the next few days. This is the official map that is included in the page for Roshydromet for population. The map for this for today, and this is next is I don't know why I don't know. This is some another models, Roshydromet model, regional model. This is the map of hazardous events that made with few, 5 I think, next days. You can see that most hazardous events are expected at the western parts near Moscow and St. Petersburg. Some thunderstorms and heavy rains are expected in the south, and some snow are expected in the Siberia, this part, yes. It's quite interesting. Next, it is the kind of meteor alarm that is issued by Roshydromet on its official website. You can click on this and you can see more detailed meteor alarms for each region, but it's only European part of Russia so far. We expected it will be more wide. The next party of Russia maybe too. And as you can see, the red ones are expected not for thunderstorms or something heavier rains, but for fires. I think it is wood fires for red ones, and some yellow, black yellow is fires and rains too. This is the link to Russian Hydromet Center official webpage, where I take some materials, and this is a page to States Research Center Planeta for satellite image. I took some from there. And now I want to tell you a bit more about Olympics, as I was involved since 2010 in Weather Information Service for Olympics. It will be very soon, in February, March of next winter. It's quite interesting, I think, to see all these concentrated efforts of, in the case of meteorology, not from Roshydromet as provider for Weather Information Service, but for a big number of other countries as well. I have not much time, so I will not go into details. I can give you only a brief introduction to Olympics, but I think it will be interesting. And first of all, I want to ask you if you know where Sochi is. I mean, where do you think the next Winter Olympic Games will be held? Okay, no Sakhalin, no Kamchatka, please. Okay, I will turn this off and I will show you the right place. Yes, it is the right place for Sochi. Isn't it funny that the most southern part of Russia, the famous Russian resort Sochi, is now the place for Winter Olympic Games? I think it is funny. Okay. Winter Olympic and Paralympic Games will be hosted by the city Sochi from 7 till 23 February Olympics and from 7 to 16 March Paralympics within 2 clusters. Coastal cluster for ice sport competitions such as figure skating, speed skating, hockey, curling, and mountain cluster for outdoor snow sport competitions like skiing, alpine and cross-country, biathlon, snowboard, sliding and ski jumping. Sochi 2014 is the most compact winter games in the history of Olympics. The distance between coastal and mountain cluster is about 45 kilometers, and it is less than 30 minutes ride along the new railway. Compare it with the Vancouver 2010 Olympics, where it takes 1.5 hours to reach from coastal cluster in Vancouver to mountain cluster in Whistler. Each Sochi cluster contains its own Olympic village, and each village is less than 15 minutes walk from each venue. More information about Sochi organizing venues you can see by this official web page. And I wanted to tell you more about, this is a vertical distribution of Olympics venue. It's the most mountain cluster sport events will take place between 650 meters bottoms and 2,300 meters tops. There is a very different climate zones in mountain cluster. It is alpine high altitude climate zone with mild snowy winter and warm wet summer, and coastal cluster has a maritime subtropical climate with warm wet winter and hot dry summer. Next I will tell briefly about coastal cluster. It is a ring for five arenas for indoor events plus outdoor stadium for opening and closing ceremonies. The weather of Sochi coastal cluster is unique for Russia. The average winter temperature is about +5 degrees Celsius. Black Sea does not freeze in winter, and due to the warm sea, winter thunderstorms are very often. North Caucasus Ridge protects Sochi from Arctic cold intrusion from northeast, but not from cold fronts from west and northwest. That may cause snowstorms, but only occasionally. Seasonal flooding risk is high because of strong winter sea storms. And if to demonstrate how unwintry Sochi is, I can say that this February, city hosted a national race walking event. This is a sport from Summer Olympics that was held at the time and place of next Winter Olympics. Mountain cluster is situated northeast of the coast. All competition will take place at high altitudes, and average winter temperature there is about -5 degrees Celsius. That is very satisfactory. And average precipitation frequency is not big, but average volume of it is high. Although the last winter was not snowy, and it was a lack of snow at the bottoms, starting from 1,500 meters above, there is always snow in the winter. The risk of avalanches and landslides are very high, especially for roads and railways. Severe weather can and other forms of adverse weather like low visibility can strongly affect the Olympics and create difficulties and even hazardous conditions for athletes, spectators and game operators, especially for outdoor events. And good weather data and forecast can minimize negative effects of poor weather on athletes, help to complete all events in time to satisfy broadcasters and spectators, and provide safety for participants and spectators. Also, good forecasts meet needs of emergency responders and transportation system operators. The weather information for trainers, team captains and sport managers must include sky weather conditions, temperature, humidity, precipitation type and amount, visibility, winds and gusts, and avalanche risks. There is 3 kinds of forecasts that will be issued. Long-term forecast 2 up to 6 days, short-term 1-2 days, and nowcasting up to 12 hours. There are some thresholds for Olympic decision makers that might be subject in the case of possible delays or even cancels of sport events. And the weather information system for Olympic Games is provided by Russian Federal Service for Hydrometeorology, Roshydromet, and consists of the following elements: Office of Main Meteorologist and Weather Situations Center in Sochi, Coordination Meteor Center in Krasnaya Polyana in the bottom of mountain cluster. They are doing data accumulation, long-term forecasting for all Olympic territory, and distribution of weather info for customers. And 5 local weather offices within 5 venues: Rosa Hutar Alpine Office, Alpine Center, Extreme Snowboard Park and Freestyle Center, Sanki Sliding Center, Ruski Gorki Jumping Center, and Laura Cross Country and Ski Biathlon Center. Local venue forecasters do short-range forecasting and nowcasting, coordination with team captains, trainers, and sport managers. First thing we need to do is to accumulate reliable data, weather data, temperature, humidity, wind speed, wind direction, precipitation, visibility, etc. So far we have about 50 automatic meteor stations. Also we use the advanced observing systems such as Sochi radar, Ahun Doppler radar, 2 microrain radars, profiler, and 4 times a day upper air sounding in Sochi. We do for the forecasting from 15 minutes up to 6 days. The main problem still is nowcasting for us. Every day we have meetings and weather briefings with the team captains, trainers, and sport managers. Also, we need to produce weather consulting with medical, media, and other services. Roshydromet provided climate data for sport managers and Olympic Organizing Committee. Science support for us is FROST 2014. FROST means Forecast Research over Sochi Test Band. Its products are very useful for us, and you can see more information about these projects in this official web page, our official web page. At the right you can see our product. It is weather bulletin for all Sochi Olympics territory. Because of the lack of the time, each forecast must be done very quickly but correctly. We start with the weather maps and satellite images. Then we have a quick view on synoptic situation and go into the mesoscale forecasting. The remote soundings such as Doppler and microrain radars and profilers are the main source for mesoscale structure, not for only forecasters, but as initial data for modeling. We use numerical weather models, global at European Center model, NCEP model, and WRF model, mesoscale and regional models, COSMORU, 7 and 2 kilometers resolution, Roshydromet model, regional model, AROM, ARPA, SIM, Harmony, GEM as well, and multi-model assembles and nowcasting system are the new experience for us on Sochi during this Olympic period. What about forecasting and nowcasting challenges is that Sochi mountain region has a little experience in forecasting and nowcasting. Also, a little historical weather data is available. With a few exceptions, the weather stations have been placed here since 2010. And what we have learned since that time, that weather above Sochi mountains can be widely unpredictable. For example, in that February, the World Cup snowboard cross event was cancelled because of lack of the snow. And 2 years ago, European Cup alpine ski event was cancelled because of too much snow. All these problems caused by intricate mixture of maritime, subtropical and alpine environment within small distance and by effect of warm Black Sea. Sharp weather contrast is another challenge, as well as wide data sparse areas. All venues sit on widely varying heights at the very steep and oppositely directed north and south mountainous terrains within a very deep and narrow valley. So each venue has its own climate. There is a team of 15 persons that dedicated to analyzing and predicting weather at that region over the next Winter Olympics, including 38 forecasters. who will do their best to hold Olympic Games safe and successfully. So thank you for your attention and welcome to Sochi 2014.
And with this, we thank you also everybody for your attention, and of course we are here for answering any questions if you like. Just returning back to the old slide, and any questions we are happy to answer.